Good morning, kids. I'm wearing my Pi Day hat. Oops, let's go this way. You guys cannot wear hats while you're studying. All right, so this is for section 7.2a. This is basically comparing exponential growth to exponential decay. I'll just remind you in general, this function here, y equals a times b to the power of x. This is an exponential function. A tells you your initial value, which is your y-intercept. I'll just call this point 0, a, because putting a 0 in for x gives you b to the power 0, which is 1, and a times 1 is a. So that's always true. Now, let's say your b value is a number, any number larger than 1. Could be 2, 3, 4, 5, or 1.1, 1.01. In all these green cases, as long as it's greater than 1, you have what's called exponential growth. And now in blue, let's say you have a b value less than 1. And what they do say is a positive number. So in other words, at the same time, it has to be greater than 0. So a number, for instance, half is less than 1. Third, a fifth, 0.8, 0.98, 0.99. Now you have what's called exponential. Let's play guess the word. D. Very good. Who said that? Q. Bad. X. You guys are terrible at this. ECAY. Nice. Who was that? Who said that? It's decay. That will look like such. Two other types of growth and decay you could have is if your initial value is a negative number. Now everything will exist under the x-axis, but as long as this number here is larger than 1, it's considered growth. That means as you move left to right, it was close to the x-axis and is now moving away. Remember, this is the point 0, -2. As long as this number here is larger than 1, this is growth. Sometimes they hide the initial value. They just give you this. So that doesn't look like a number. Some of you say that's not a number in front. Now you gotta do a little work. Remember, Desmos will solve a lot of your issues today. That is how this one looks. Because currently, this means today, on day 0, you're at a value of -1. The next day, you're 5 times larger, so to speak. The next day, 5 times larger. This could be talking about debt or who knows what real-life experience it is. So that's that. This one is primarily going to be decay. And again, you're just looking for that growth factor, that number basically in the parentheses. Is it larger than or less than 1? Here's a sort of a real-life scenario. Let's say you buy a brand new car for $28,000. And they say that this car loses 30% of its value every year. That's fairly accurate. The value of that car would start here. That's your y-intercept today at $28,000. And it goes down some. It's not going to go down that same amount every year. It's not a slope situation. Because now when you lose 30% of this value, there's less money to lose. And it will slowly start to do that sort of thing. If you think about it, this means that you have let's say a 30-year-old car. According to the graph, if this was 28,000, this value here could be $758. That's why my son's car which is 25 years old, would have the point 25, 38, because it's probably $38. So if you guys can get your coins together, there's a nice 1996, 1995 Honda Civic for sale. Oh. Gets 41 miles per gallon. And that's that.